In January 2006, a tiny spacecraft left the Florida coast and began the longest and furthest journey of human exploration ever. 9 years later, that spacecraft became the first to visit the dwarf planet Pluto, 5 billion kilometers from home. That Pluto mission stands as one of humanity's and America's greatest accomplishments. But it's one of those big things that begins with a very small thing, in a way you'd never expect. With a postage stamp. Actually, this postage stamp.
That's a great way to start.
This is Dr. Alan Stern, a planetary scientist who would eventually lead the Pluto mission, but we'll talk more about him in a minute.
The United States have been first to every planet in the solar system. To Venus, first to Mars, first to Mercury, Jupiter, Saturn, Uranus, Neptune. The United States Postal Service, they published a set of commemorative stamps, and for every stamp it had the year and the name of the mission that did the first exploration of that planet. Well, they had to decide what to do about Pluto, and rather than leave it off the list, they created that stamp that you just held up, and it says Pluto, not yet explored, which left some important unfinished business.
In 2006, one of these stamps hitched a ride on the very spacecraft that would explore Pluto and its system of moons. That mission is called New Horizons. It's been an enormous success and has forever expanded our understanding of the outer reaches of our solar neighborhood. Although thousands of men and women were involved in the exploration of Pluto, one man was at its core as the project leader from the very start. Today, we're joined by the mission's founder and leader, Dr. Alan Stern.
It's great to be here, Jared. Thank you.
So settle in, because the story of the New Horizons mission to Pluto is as exciting and dramatic as the dwarf planet it would eventually study. So these are the first pictures of Pluto, which, by the way, is 100% a planet.
Well, Pluto's absolutely a planet, and so are north of 100 other objects in our solar system.
So we're going to talk about that more in a later episode. Pluto was discovered by Clyde Tombaugh in 1930, a guy who was just 23 years old. He discovered Pluto by taking multiple photographs of the sky through a telescope, night after night, and flipping between photos to see if anything moved. In Greek, the word planet means wanderer, because unlike the stars, planets wander across the sky. And that's how Clyde knew that Pluto wasn't a star, it was something more. And he had to use a telescope because Pluto is so small and so far away that it can't be seen with the naked eye or even with binoculars. For decades, that's about all we knew about Pluto. That it existed, that it was small, that it was far away. A few years ago, I made a video of the scale model of our solar system using a football field and a soccer ball sun, and at that scale, Pluto was the size of a grain of sand over 1,000 yards away from the sun. Even with the Hubble Space Telescope, one of the most powerful telescopes ever built, Pluto is just a blurry blob. It's just too small and too far away. If you were to study Earth from the same distance, it would look like this. What could you learn about Earth if this is all you saw of the planet? Not much. To study a planet, to really find out what's there and what it's like, we have to go there.
The reason that we send spacecraft to the planets is we can get very close, and therefore we can get much higher resolution. And the image that you're talking about from Hubble was the best image of Pluto ever made before New Horizons, and it's just a fuzzy blob. You really can't see much of anything. And obviously, when we did explore Pluto, because we could bring the cameras and the spectrometers very close, we got very detailed maps and very detailed information on the surface composition. You just have to be close. It's been true ever since the first missions to Mars. When you are close, you can bring certain kinds of instrumentation to sample the atmosphere or study the magnetic field or observe from special angles and geometries that you can't do when you're looking from far away. Is what's revolutionized our knowledge of our entire solar system, because we sent space to all the planets and virtually all the major types of small bodies in the solar system.
So let's talk for a minute about Dr. Alan Stern. Alan Stern is a renowned engineer and planetary scientist. He spent a few years at NASA as their chief of all space and earth science missions. He's explored the Titanic wreck, he's explored Antarctica, and now he's an astronaut payload specialist for NASA on board a Virgin Galactic mission. He's had a really successful career, but is probably most well known for leading the very mission we're talking about today, New Horizons. He wrote the book on exploring Pluto, literally. Dr. Stern first proposed a mission to Pluto in 1988, but at the time, most scientists at NASA felt that the costs far outweighed the educational value of a Pluto mission. Deep space missions are expensive. They're some of the hardest and most complicated challenges humans have ever attempted, requiring thousands of scientists and engineers to build, test, launch, and operate. And NASA's budget is limited. It's only about 0.5% of the total federal budget.
When the Voyager mission, which, so historically trailblazed its way across the giant planets, it's Jupiter, Saturn, Uranus, and Neptune, they made a decision to do some in-depth studies at Saturn that, from an orbital trajectory standpoint, precluded them from being able to go to Pluto. So when they finished at Neptune, they were done with their planetary exploration.
NASA can only afford 1 or 2 deep space missions in an entire decade, so the community has to strongly believe that any proposed mission is going to be worth it. For Alan Stern and the Pluto Underground, that mission was Pluto.
Our view was that everything that we were learning about Pluto from afar showed that it was just fascinating and promised to be really spectacular scientifically. And of course, it had not been explored, and we could show it's got this fascinating moon that's half its own size that was formed in a giant impact. It's got this fascinating escaping atmosphere. It's got surface markings that indicate it'll have interesting geology, so forth and so on, that made a strong scientific case. For me personally, it was also about that the United States led an exploration of the solar system. That there was unfinished business, that we should lead again.
It took nearly 13 years to convince NASA. Pluto missions were created and then canceled 5 different times. But in December of 2000, NASA announced that any space contractor could compete to design a Pluto mission. The winning design had to meet 3 criteria. It had to be science-rich, it had to arrive at Pluto before 2020, and it had to cost less than $750 million. That's about 20% what the Voyager missions cost. Within an hour of NASA's announcement of a Pluto mission, Alan Stern was called by both JPL and APL and asked to lead their teams for the competition. And he picked the underdog, the Applied Physics Laboratory, a team that had never launched a deep space mission, but one that had demonstrated that it was deeply committed to exploring Pluto above all other projects. So Alan Stern and APL pitched a mission that they called New Horizons, a medium-sized piano-shaped spacecraft powered by a tiny nuclear reactor and covered in a suite of cameras and science instruments. But no new technologies would need to be invented. Instead, it would only use proven instruments that had flown on other missions. It also had an unheard of amount of redundancy built in, including 2 separate computer systems and very few moving parts.
We made a lot of hard compromises that helped us get the cost down. The real challenge was to get a spacecraft to Pluto, not just to get it on the drawing board and then find out it'd be too expensive and get canceled. Is that we took the calculated risk that even though it was just as long a journey as Voyager had gone on, that we would only be able to afford 1 spacecraft, not 2. And therefore, we needed only 1 rocket, not 2, and 1 set of mission controllers, not 2. And it was taking a calculated risk, and it worked out.
On top of that, New Horizons would cut down costs by going into a low power mode during the 7 years between Jupiter and Pluto, allowing them to have a skeleton operations crew that was only about 10% of the Voyager teams.
Our spacecraft was the first to extensively use hibernation for 10 years. That also helped save money. So in the end, we made a lot of small choices that added up to doing the mission on a dramatically lower cost than Voyager and retaining more data and of higher quality than Voyager because we had such advanced technology compared to the Stone Age 1970s technologies that Voyager had to use for its time.
All of those design decisions were factors in why NASA finally awarded APL's New Horizons mission in late 2001. The next 5 years were full of drama and politics that actually killed the project and then revived it more than once. We don't have time to go into that here, but it was a wild ride just to get things off the ground. Through it all, APL's and Alan Stern's persistence to get to Pluto never wavered, and it would eventually pay off.
7, 6, 5, 4, 3, 2, 1.
In January of 2006, New Horizons was launched from Earth aboard an Atlas V rocket and began a journey toward Jupiter, which only took about a year. New Horizons used a clever trick called a Jupiter gravity assist. Basically, by flying close to Jupiter, it stole some of Jupiter's orbital momentum, transferring it from the planet to the spacecraft, and making New Horizons go much faster. It's like a space shortcut, and it saved 3 years from the travel time. Plus, the team got to try out the onboard instruments as they passed Jupiter and collect some science along the way. After Jupiter, New Horizons was going extremely fast, 58,500 kilometers per hour, twice the speed of the fastest space shuttle mission. The thing was, with Pluto's weak gravity, New Horizons had no way to slow down when it got there. So New Horizons was not designed to slow down at Pluto. Instead, this was a flyby mission. A flyby mission is when a spacecraft is launched toward an object, but the spacecraft never slows down. It literally just flies by. Since New Horizons was going so fast, by the time it finally arrived at Pluto, it would only have minutes to take its best, highest resolution observations of the dwarf planet. After that, New Horizons would zip right past Pluto and head into interstellar space. So the team at APL had to make sure that every second of that flyby counted. To do that, New Horizons was packed full of science instruments with some really fun names. There's Lori, a camera with a telescopic lens to get really zoomed in pictures, photos like these. There's Ralph, which is actually two different colored cameras. Not only can Ralph see in red, blue, and green like humans, but it can also see in near infrared and it can see methane. So it could visually show scientists the temperatures on Pluto's surface and the exact location of methane and water. Then there's Alice, a small telescope that can see in ultraviolet light. It can take photos of Pluto's atmosphere and figure out which gases were there just by looking. There's Pepsi, the particle detector that collects charged particles in the space around Pluto. It's a bit like sticking your tongue out while it's snowing. Pepsi essentially tastes Pluto's atmosphere. There's SWAP, a device for figuring out how Pluto has managed to hang on to its atmosphere and how much effect the solar wind from the sun has in stripping the atmosphere away over time. The last major science instrument is the Student Dust Counter. Believe it or not, this was designed and operated by college students. This instrument is a dust sensor that can detect and measure the size, speed, and direction of dust particles in the space around Pluto. And that brings us to this large dish on top, the high-gain antenna that sends and receives signals with Earth. Communication speed at Pluto is slow, about 2 kilobits per second, far slower than dial-up of the 1990s. If you tried to download a single episode of the show For All Mankind at that speed, it would take you 7 days to watch it. Super slow. But during the Pluto flyby, New Horizons collected a library's worth of data in just a few hours. So APL performed a bit of clever design here.
It was a 9.5-year journey to Pluto, across 3+ billion miles of space. We realized early in the development, if we made the communication system less capable, it would require less electrical power for the transmitter, and that we could save cost of the nuclear power supplies, because instead of needing 2, we only needed 1. And the logic was this: look, if we can wait 9.5 years to get there, we don't need all the data home in a month. We can take a year to get it all back. So another calculated risk, but that allowed us to get the electrical power requirements down and only need to buy 1 instead of 2 nuclear power generators. Remember, you can't use solar arrays out there. And those nuclear generators were almost $100 million a piece. So by squeezing into that lower power budget, by accepting lower data rates, we saved $100 million right off the bat.
Oh, and there's one more thing on board New Horizons, that original stamp from 1991 that started it all. You know, the one that said, Pluto, not yet explored? Well, the team sent that very stamp to Pluto. There were other mementos too, like 2 American flags, Florida's state quarter, and the ashes of the Pluto discoverer Clyde Tombaugh. So now it's July 4th, 2015, and after 9 years of zooming through space, New Horizon is just 10 days away from Pluto. Then, around 2 p.m. on July 4th, the spacecraft suddenly went completely dark. No signal, no warning, nothing. This had never happened in New Horizons over the entire 9-year flight from Earth. And now it's only 10 days out from the flyby, and the spacecraft is dead silent. This is the kind of thing that would happen if your spacecraft is destroyed. Although it was unlikely that it would ever hit a piece of space debris, it wasn't impossible. And New Horizons was traveling at 16 kilometers per second. At those speeds, even a tiny rock the size of a grain of sand would destroy the spacecraft. Something similar happened to the Mars Observer mission in 1992, and it went silent just 3 days before it reached Mars and was never heard from again, ending in failure. With unmanned missions like these, if there's a serious problem, it's over. There's no way to see New Horizons, there's no way to go out and fix it. It's entirely on its own. So on July 4th, the team waited by the computer monitors with bated breath. About 90 minutes later, New Horizons suddenly phoned home again, and the team let out a sigh of relief. The spacecraft informed the team that its main computer had been overloaded and it shut down to protect itself. And right before the flyby, what horrible timing! Thank goodness for that backup computer. But in the process, the probe lost the entire mission plan known as the core load. That was the complicated set of instructions that would capture all of the data during the flyby. So not good, especially because New Horizons was just 10 days away. With sheer determination, the team worked tirelessly around the clock to rebuild the mission plan and re-upload it to the spacecraft. They worked, ate, and slept in the office to get New Horizons up and running again. Within 3 days, they managed to restore New Horizons with only 1 week to spare before the flyby. Whew, mission saved. At 4 p.m. on Monday, July 13th, just 16 hours before the flyby, New Horizons took a photo that would stun the world. Pluto had a heart. The probe would spend 36 hours making 236 separate scientific observations of Pluto and its system of moons. But this single picture captivated the world. After a century of imagining what this tiny world would be like, no one expected something so adorable. Finally, after everything this mission had gone through, New Horizon arrived at Pluto on July 14th, 2015, and performed the flyby flawlessly.
Expected amount of data.
Copy that. Looks like we have a good data record.
Pluto turned out to just be spectacular. In fact, it exceeded all of our expectations. Generally, as you go to smaller and smaller worlds, you find less and less complexity. Pluto broke the mold on that. Here, it's only the size of about the continental United States, and yet it had complexity that rivaled Mars. Pluto, out there, all by itself, this tiny little world that, by all accounts, should have cooled off. We found evidence, many kinds of evidence of activity on Pluto's surface. We found evidence for past geysers, for past liquids on the surface. We found nitrogen glaciers and volcanoes the size of Mauna Loa that spew ice, clouds and hazes in the atmosphere that stretch up 500,000 feet. Those mountains, their construction is primarily of water ice. They have a thin veneer of more exotic ices on their surface, but we know now from fingerprinting the composition that that's the primary material out of which all those mountains are constructed. Largest feature on the surface of Sputnik Planitia, this giant nitrogen glacier, is roiling and overturning every few million years, 4 billion years after Pluto's formation. And we didn't think that planets that small could continue to be active billions of years after their formation. They just completely rewrote the textbooks about the complexity of small planets and the ability of small planets to be intensely active even today. It's just a sci-fi world.
So on July 14th, New Horizons flew by Pluto and its system of moons, and then it kept going. Remember, it has no way to stop or to slow down. So what comes next? Well, it's in the name, New Horizons. As it turns out, exploring Pluto was just the beginning.
We discovered and then fired our engine to go off to our next flyby target, which was called Arrokoth, the first ever Kuiper Belt object to be explored. And we had to travel another 1 billion miles, and it took 3.5 years to get there. And in 2019, we made the first exploration of Arrokoth. It taught us a tremendous amount about the formation of these small bodies out there and the formation of planets like Pluto. We have studied 36 other Kuiper Belt objects that we passed in the distance, some dwarf planets that we've observed in ways that you cannot from the Earth or from the James Webb or the Hubble Space Telescope. We've made astrophysical observations that have actually produced breakthroughs for extragalactic and cosmological science. We've been studying the sun's outer heliosphere, which the Voyagers also studied when they were at these distances. And all those things are going on at once. We're going to continue to do that as long as NASA will fund the mission until we leave the Kuiper Belt, which should be in 2027, 2028. Spacecraft is in perfect health, all 7 of the scientific instruments, and we have the power and fuel to run the spacecraft, we think, until the year 2050. So we're not nearly done.
So that's the story of New Horizons so far. A story of how something very small, like a faint dot in a telescope or a cheeky postage stamp, can lead to something very big. The discovery of an entirely new and wonderful world through the efforts of thousands of men and women.